We're going to move on now, and we have a really good tech corner for you today. We love when we can do tech corners this way, where we can have a guest come into the studio and show off a new product. We have Chuck Marks of OGP with us today, and Chuck's going to show off the new Vici Vision system, which is new to North America. And I'm going to throw it to Chuck and Dirk right now and show it off. Take it away, guys.
Okay, well, so again, Chuck Marks, thanks for coming back and visiting us up here in Chico. It's a slightly larger place than where you were last time.
There's a little more room, yeah.
When you came last time, what equipment did you show us?
We brought the Snap digital measurement system.
Oh, that's right, the Snap. And this time we have the Vici Vision.
Right, the Vici Vision, OGP is very proud to be able to bring that to North America. New product, new offering for us. What it is it's a shaft measurement system, and it utilizes a vertical travel profile light, and we're able to do a single pass and get a lot of dimensions very, very quickly.
Okay, run us through it.
All right, so I'm going to go ahead and start an inspection routine here. What you're going to see is there's going to be light coming from the left-hand side here. We have a collimated light source. It's going to come over to a camera array on this side, and we're going to see it scan up and do the measurement. So what we see right here is the system goes down at homes, does a quick check, make sure everything's working properly. We then move in, and it's going to move up, and it's going to do first a linear scan here that acquired all the dimensions in that particular orientation. You'll see it begin to do a rotation where we'll check some measurements on another orientation. And then we're going to do right here a dynamic measurement in which we're checking the roundness of the, in this case, the head of the screw. All right.
And the dynamic rotation works by simply what, rotating the stage as the camera stays in one place?
That's correct. The camera stays static. As we rotate around, we're counting the scale counts as we rotate. We're then taking the measurement data, plotting that against it, and then we can actually look here, and it'll give us a nice roundness plot. You can see there on the software, kind of lets us know that there's definitely a little lobing going on here. One of the great benefits, the Vici X5 here is really designed for the smaller medical parts. So dental implants, the bone screws like we have on here. The reason why is we have a very high definition camera array set up on this particular one. Travel on this one is 16 millimeters wide by 100 millimeters long.
Okay, and just to clarify how this works again, you've got a green, it looks like a green collimated light source.
That's correct.
Hitting the object from one side, and then what, like a line scan camera on the other side that's tracking with it.
That's correct. As that moves up, it creates the 2D profile of the part. And
then you simply rotate the part so that you can capture the profile from different angles as you go.
That's correct. That's correct. So some of the dimensions we can do, for instance, here on the screw, we can check some of the diameters measurements. If we ever want to see how that's tracking, we can just right mouse click and go to measure trend. So there, right there is the tracking that we've done over several parts. So you can check your process control as you're going through there. We can look in. One of the really nice things that we can handle on this is threads. Okay, so the software has a built-in library of different type of thread types, and by taking a look at that, it'll understand the pitch and the helix, and you can do a lot of the measurements, your pitch diameter, your major minor diameters, as well as some measurement across the roll measurement across the wire.
Now, why would you want to, I mean, once you've got all your pitch and your diameters and all that, why would you want to rotate the screw? I mean, I'm used to seeing screw measurement basically on regular optical comparators, so why rotate the screw? What's that buy you?
A couple things is, one, we can rotate to the start of a thread. So let's assume that, you know, maybe we want to fit this against CAD, or we want to make sure that we always rotate so the thread start is at a specific orientation. Then as we come back through, we know that we're always starting at the same location. We don't have to worry about any thread adjustments. That'll help us let us know the effective length of the thread much better.
Okay, and besides threaded parts, what other types of parts do you measure?
Well, any type of turn parts or shaft parts that have cylindrical attributes. Right here we have a different part. Once again, a medical type part. It's an abutment for dental implants. Just tighten this in here. Just go ahead and pull up the routine real quick. It's very simple. Now, we don't have it set up here, but we certainly have the option of putting a barcode reader. So my operator could just walk up, hit the barcode scanner, and bring it up. I just hit start right here, and you're going to see, once again, this is going to do a measurement. Now, you're going to notice something here is we're going to use a rotation to present the part in the two orientations that we need. Okay, so the first part here, we come up, we scan, we get the overall height. We then drop down, and now we're going to scan this around and you can see it rotating there. So it's measuring, and now it's going to rotate with the abutment facing toward me. Okay, so now when we do this scan, we're getting at the profile, so we can check the angle of that that shaft as it comes along from the center line.
So I'm assuming to find the profile, it's looking for. It can detect when it's reached that point where you're seeing the full 90-degree profile to the part, right?
That's correct.
So basically, when you program it to say I'm looking for the profile. Then it takes care of aligning to make sure it actually has the profile.
Absolutely. If we look here at the model window here, we just rotate that until it's at the maximum left position, and then that lets us know that we've reached that 90-degree angle position.
Now, is it doing that after it's collecting the data, or is that doing this orientation and then doing the scan?
That's right. It does the orientation first, and then we go through and we do a secondary vertical scan and capture all the data. The nice thing is, unlike an optical comparator where you have to grab each point individually, we can do one scan and then go back in and analyze any of the data that we need to do from there.
Okay. And one thing I forgot to get back on the screw measurement. When you were taking, I think you called it the dynamic measurement.
Right.
So that's actually looking what that I think you pointed out is that actually lets you see the roundness of a part, right?
Yes.
Okay.
Yeah, that'll allow us to do that.
Throw this one, conicity. I mean, if you were measuring like this has a taper to it. I see on this part. You can also look at that, or can that?
We could go through and plot a number of different diameters.
Okay.
So a known height, check that diameter, index up, and then just keep moving upward in that manner. Yeah.
All right. Got it.
Another thing it lets us do here, if we look at this measurement right here, what that does, it looks kind of unique there, is that's actually checking the clocking, the width, and the angle of each of the flats. There's a hex down on the bottom of this, so it's letting us know is each hex face opposite to one another, and then what's the angle between the adjoining sets of hex faces.
Okay.
Yeah,
okay.
So it's very, very good.
Now, what did you already say? What size parts you can fit on this machine?
This particular machine, 16 millimeter diameter by 100 millimeter long. Now, we have a number of offerings that go much larger, including 120 millimeter wide by up to about 1,250 millimeters in length. So we can do some very large parts. Capacity gets up around 200 pounds when you start getting into the bigger machines.
And is this a shop floor tool or a lab tool? I mean, temperature compensation, that sort of thing?
On the X5 that we have here, it's designed to kind of be in a controlled environment.
Okay.
A lot of the shops that are making these parts are very controlled, so we're probably good putting it near the floor there. If it's not, then you need to put it in a lab. A number of the larger machines have built-in environmental compensation. They have some doors that go over the front, light bars to make sure you don't stick your hand in there while it's doing some measurements, and a lot of compensation that can handle being out on the shop floor.
And what kind of price range?
Price range varies from the upper 40s up to about $85,000, $90,000, depending on some of the options. There's a lot of different accessories that you can use for holding the parts and the different size travel machines.
And I've noticed, I mean, obviously to run it was very easy. You just basically hit the start button, select your program, hit your start button, it goes. What about programming the machine?
Programming is not all that difficult. Once we have that vertical scan, we can bring it in here. And if we want to come in, and I'll just do a quick measurement diameter here. Pull up the width right here. And we will go with, get back in here to the measurement. And we'll pull up a new one. There we go. Tell it what we're going to do. Tell it we want to do a quick diameter. And we can just grab this, slide it right up here, shrink the size down, and hit calculate. And there you go. There gives us the diameter right across there.
You just drew a box. You drew a box around the area of interest, told it what kind of measurement you were going to do. It does the rest, including, I'm assuming, if you need some sort of alignment, that is handled automatically.
Right, yeah, there's types of alignment that can be done for any sort of part orientation.
Okay, great.
Yep.
Well, Chuck, I appreciate it. This was the Vici Vision. Did I have that right? From OGP.
Yep.
And if you got any further questions, there is a link on the bottom of our screen that people can get out there, and I believe that links directly to the Vici Vision, right?
I believe so. You can also go to www.ogpnet.com. You can find out more about the Vici, as well as find your local OGP channel partner.
Okay, appreciate it. Thanks, Chuck.
All right, thanks.
Okay, Mike.
All right. Well, thank you, Chuck. Thank you, Dirk, and of course, thanks OGP for providing the Vici vision to us for today's Tech Corner. Always good to have a guest in the studio to demo the newest product. And again, if you want more information on the Vici vision, just check out the link right below the player page right there.